now let's turn to the Sydney to Santiago flight on the flat Earth map. And this is where things get interesting. This is the one which is going to make this challenge tough. Here is the flight on the flat Earth map if a direct route is taken. And as you can see, this flight would be way longer than the other flights, at least double the London flight. Now, I've been accused of not understanding the flat Earth side, and I've been accused of not spending enough time looking into flat Earth. 3 years is apparently not enough time. Now, when you've done a calculation, look at your answer. And if it's not at least 3 times or so the length of what you calculated for the London flight, you may want to double check your math. Now, I think I'm probably going to get some complaints from the flat Earth side that they're not sure how to calculate the distances, and I have a solution for you. Check this out. Gleason's map has a scale on it. Notice it says at the top there, 60 miles to the degree. This is for degrees latitude. And from that, it defines the scale for the rest of the map. And people tell me I'm not familiar enough with the flat Earth model. Come on now.
I believe you've spent a lot of time researching flat Earth, Will, but obviously not enough time researching how a Gleason's map works, or you probably wouldn't have made this video. I've got videos over a year ago going into detail on how to measure distances on the Gleason's map or AE map the way Gleason instructed. It's not just the latitudes he shows how to use. The top ruler's for latitude, the bottom ruler is for longitude. So you're not using the map properly. So I believe you're accidentally straw manning it. I'm not going to go into detail here, but you can check out my old videos. But I'd give multiple examples, including the width of Australia and, you guessed it, Santiago to Sydney. So there's the distance from Santiago to Sydney using the Gleason's map or AE map properly. Nowadays, there is an app for that. There's probably multiple apps for that, but I use the NIST AE map generator. You can punch in the radius for whatever size you want. Here I punch in 7,000 kilometers. So from end to end, the diameter is a maximum 14,000 kilometers, which comes out to roughly about 8,700 miles. So add about 700 or 800 miles for curving around Antarctica, and you get about 9,490 miles. But this is not my official entry. I just wanted to show you some new information for you. And if you look on here, you'll see right there Santiago, right before the border. And then I show Sydney, which is right before the other side border. And if you haven't seen, this is the AE map centered near the equator by the prime meridian. You get 2 poles, 2 natural rotations. Now I've animated the sun and stars, putting the sun over the exact latitudes. And I've also made some recent models trying to make improvements each time, which you'll see on screen. So I've made a few adjustments, added a little perspective. But for people like McToon and Ruhip, who say that using the AE map is using the globe, then quit ragging the AE map. You can't have both. But just because the distances are similar, not exact, but similar, they try and claim it's a globe model, but then want to rag the AE map because it uses the celestial sphere, the celestial hemisphere to be exact. The math is calculated out hemispherically because that's the only way to do it. Their argument is it uses the Haversine formula, which only works on the surface of a sphere, which is completely wrong. The Haversine uses coplanar angles. It does not work on the surface of a sphere. You cannot do the calculations from the surface of a sphere. You need coplanar angles. You need a plane and a hemisphere above, like the celestial hemisphere, not a globe. Thank you for watching.